Hello and welcome to this lesson from the unit P5 Space for Reflection. This lesson is on the equations of motion, and the general aim is that you can use the equations of motion in a variety of examples, and in particular I'm looking for people at the C grade level to be able to use these two equations on the left, and you should be able to use the first equation to work out either V or U, and you should be able to use the second equation that might involve a change of subject, and to get a B or an A you need to be using the equations on the right, and that may involve again a change in subject. Now what I intend to do is to go through the main steps in the calculations by looking at several examples of calculations that you could be asked to do. It's worth noting that these questions are relatively difficult and are of the higher demand compared to what you may actually receive within the actual exam itself, but of course it's worth making sure that we can do those, and you should gain great confidence from completing them. It's my intention in this lesson to actually teach you the steps that are involved in these calculations by looking at three challenging examples. It is also worth noting that these equations can always be used when examples where there is a constant or steady acceleration. A very common example where that happens is when objects are falling because they are falling under the acceleration due to gravity. Now at first glance these equations may look unfamiliar to you. I don't intend to derive them all today, but I will show you how we get the first equation, V equals U plus AT, from a very well-known equation that you've learned about in a previous topic. Now in P3 you learned about acceleration, and you learned that the equation for acceleration was equal to the change in speed, well I'm going to use the term velocity now, divided by the time taken. Now rather than writing out words each time, it's often more convenient to use symbols, so I'm going to write this equation again in using symbols. I'm going to use A for acceleration, I'm going to use V for velocity, but I'm going to use that delta symbol just to show there's a change in velocity, and I'm going to use T for time. Now when we talk about a change in velocity, we're talking about an object going from an initial velocity, a starting velocity, and that's changing to a final velocity. And so what we can do is we can break delta V down into this, basically, where V is the final velocity and U is the starting velocity. So the change in velocity is just the difference between our final velocity and our starting velocity. And we can put that back into our equation so that we now look like A is equal to V minus U over T. Now I want to arrange this into a format that's more convenient, perhaps more convenient for example calculating the final velocity of an object. So I'm going to take the T over to the other side, so we now have V minus U is equal to AT, and then I want to have V on its own, so I'm going to take the U to the other side, and of course that becomes V equals U plus AT, and hence we now have the equation of motion that we started out with. So this just goes to show that the equations of motion are derived from the standard equations that you already know. They're not anything new, that's just in a slightly different format, and the symbols may be unfamiliar to you. So if we're talking about the symbols, we need to know what they mean. So I'm going to go through them now very quickly, and you will need to make a note of this in your books. So S is actually not speed, it actually stands for displacement. Now displacement, remember, is the vector version of distance, which means that it's measured in meters. So it's how far you travel in a stated direction. We then have U, which, as I've already mentioned, means the starting velocity or initial velocity. And of course velocity is measured in meters per second. And then finally V, which means final velocity, which is measured in, again, meters per second. A stands for acceleration, and remember that's measured in meters per second squared. And then finally T, which is time, And of course that must be measured in seconds. So let's start off by looking at an example where a train starts from rest at a station and accelerates at 0.2 meters per second squared for 1 minute until it clears the platform. The question asks us to calculate the velocity of the train after this time and the length of the platform. Because we're talking about vectors, direction is extremely important, so we need to decide on which direction is positive, and that's our first step. So I'm going to take the train as moving to the right along the platform, and that will be the positive direction. So any vector acting in that direction will be positive, any vector that's acting in the opposite direction will be negative. In step 2, we need to look at the question and decide on the information that we're given and the information that we need to find out. And we do this by actually following these steps up here. I always write this out, S, U, V, A and T, and then I look at the question and decide on what I'm given and what I need to find out. So first of all, S is the length of the platform, which we need to actually find out. It's a displacement. V, we're asked to find out the velocity of the train at the end of the platform, so it's the final velocity, so that's V. So what other things are we actually given? Well, we're told that the train starts at rest in the station, so that means the starting velocity is 0 meters per second. We're told that the acceleration is 0.2 meters per second squared, so I can write that in here. And we're told that it travels for 1 minute, or it takes 1 minute to travel along the platform. And of course that needs to be in seconds, so our time is 60 seconds. Once we know our values, and once we have 3 of our values, we can always work out the other 2 by using the equations to the right, and it's just a matter of choosing the equation that we need. So let's work out V first of all. So we want an equation that connects U, V, A and T, and pretty clearly when we look at this list of equations, the equation that has those 4 things in it is actually the equation at the top. So when I'm answering the question, I want to show my working out, so I'm going to start off by writing the equation that I'm going to use, V equals U plus A T, and then my next job is to put the numbers in that I know. So U is equal to 0, so it's plus, and then we have 0.2 times 60. And I've put that into brackets just to remind myself to keep them together and to do that multiplication before I do any addition. So 0.2 times 60 is 12, plus 0 means that the final velocity as the train gets to the end of the platform is 12 meters per second. Now my next job is to work out how long the platform is, and I need to use an equation that has got S in it. I now know all the other components, so I could use any 3 of these equations. I want to choose someone that's relatively straightforward, so I'm going to use this one here. Because it's asking me to find out S, I won't need to do any rearranging at all. So again, to show my working out, I need to start off by writing the equation that I'm going to use, which is S equals V plus U divided by 2 times T. V is 12, U is 0, and that's divided by 2. We're going to times that by 60. So 12 plus 0 is 12, divide that by 2 is 6, 6 times 60 is 360, and remember that's meters because it's the length of the platform. So what we found out is that our train accelerates from rest, and at the end of the platform is travelling at 12 meters per second, and the platform is 360 meters long. Now this is a slightly different example, so we're talking about vertical motion now, and example is going to show you the importance of specifying which direction is positive and which direction is negative. So the example says a ball is thrown vertically upwards with a starting or initial velocity of 10 meters per second. Calculate the maximum height it will reach above its starting position and the time it will take to reach this height. So looking at the question and trying to decide which direction is positive, I'm going to take going upwards as being positive, and anything that's acting downwards will be a negative. So what information are we given? Well, the first bit of information that we need to work out is actually the maximum height that it's going to be reaching. So we need to find out what S is. And we also need to find out how long it would take to reach this height. So we need to find out T. So S and T we are not going to be given. So what are we actually given? Well, the starting velocity is actually 10 meters per second. The acceleration don't seem to have been given, but we all know that this is down to gravity, and the acceleration due to gravity is 10 meters per second squared. Now remember what I said, upwards is positive, gravity acts downwards, which means it has to be minus 10 meters per second squared. So that minus is there because it indicates that the gravitational pull is acting downwards. This ball will be decelerating or slowing down as it rises. So we still need V, because we need three things to be able to calculate the other two. And the thing that you've got to appreciate is as the ball rises, what's going to happen is it's going to get slower and slower and slower until finally at the top of its height that it reaches, its actual velocity is going to be 0. So here the final velocity is 0 meters per second. So I'm going to work out the height that the ball actually reaches as it's thrown up. So I'm going to need an equation that connects S, U, V and A. That equation is my bottom equation here. So I can write that out. V squared equals U squared plus 2AS. I'm then going to put the numbers in. So V is equal to 0, U is equal to 10. And now this is important. This, because the acceleration is actually a negative number, this becomes minus 2 times 10 times S. So it looks very complicated at the moment, but bear with me, just keep the numbers going. So 10 squared is 100, minus 2 times 10 is 20S, and that looks a little bit more simpler. Now in order to make this work, what I'm going to do is I want to separate these two terms on the right hand side. So I want to take one of them over to the left hand side, and because I don't like this negative here, I'm going to take the 20S to the other side and make that positive. So that means that 20S will be equal to 100, and then to find S, all I have to do is divide 100 by 20, which gives me a height of 5 meters. So the ball is thrown up and it reaches a height of 5 meters. So all that's left for me to do now is then to work out how long that takes for the ball to reach the height that it reaches. So again, I can use any of the equations that have got t in it. So I'm going to use the top one because again it looks the most simple. So v equals u plus at. Again, I put the numbers in. V is equal to 0, u is equal to 10, a is equal to minus 10, and then t is the one that we're trying to find out. So very similar to before, I want to get rid of the minus, so I'm going to take the 10t to the other side. That makes it positive. That means 10t is equal to 10, which means that t will be equal to 10 divided by 10, which is 1 second.